Good afternoon, everybody. Welcome to Xilinx Advances in Data Center Acceleration Solutions. I am neither Manish Muthal or Ravi Sunkavalli, in case you can't tell. My name is Jim Dworkin, and I'm in the data center group of Xilinx. Very happy to be here today. Thank you for coming. Old school. So I want to talk to you about our journey as a company that we're on towards building the adaptable, intelligent world. So we have everything, as you all probably very well know, we have everything intelligent and connected is the vision. It is driven by the explosion of endpoints out there, measured in the billions, heading towards the trillion plus, and obviously based on that, deployed at massive scale. So we're trying to build the adaptable, intelligent world where the end use cases for all these devices in these markets is quite dynamic. So the use cases are changing, they're evolving, and they need rapid innovation and deployment. And that really dovetails well with our technology that we bring to the market. Okay, that's backwards. So data center acceleration. This is not science fiction anymore. It's actually happening, and we claim everyone is doing it. The trend towards heterogeneous computing in the post-Moore's Law era, driven by the exponential data growth with all of these connected endpoints that we have and the east to west traffic that happens in the data centers that support them, is here. And AI, specifically machine learning, is a market that I think we all understand whose time has come. It's been growing nicely for a while now. So all of these factors contribute, and we at Xilinx segment the data center into compute, storage, and networking applications across multiple deployment types and end markets, anything from public cloud to private cloud, hyperscale, enterprise, obviously hybrid cloud, and the legacy high-performance computing segment as well. So we have solutions that span all of those market types across compute, networking, and storage applications. So data center applications are so varied, and with their adaptability, they need platform-based solutions. So we don't expect, actually what we like to enable is for end users to use our technology without having to deal with the underlying complexity of the hardware that enables it. So again, looking at compute, networking, and storage, you see that the workloads are varied. And these are just a sampling of some of the most popular applications that are being driven out of each of these end market segments. So I'm not going to read through them all, but what I'm really here to talk about is our platform approach to enabling these applications and enabling them to scale with good TCO advantage. You're all thinking to yourself, when is he going to get it? Down means forward. So in October last year, we launched a brand new product family called Alveo. I suspect you've heard about it. These are PCIe acceleration cards, and this is really a foundational element for us as a company to enable these platforms in compute, networking, and storage that I just spoke about. But what does a platform mean? What is it? So for us, it has multiple components. So we have our IDE, so our traditional development tools that allow the hardware and software developers to program the low-level hardware and to get the highest performance out of it. And so on top of that, we have firmware, embedded firmware and runtime, meaning drivers and host-side support. These components of the platform enable the software developers to work at the speed that they're used to working at in C, C++, and other languages. Then on top of that, you have libraries, compilers, and middleware that need to be ported on an application-specific basis to enable the application developers to efficiently develop those applications that service compute, storage, and network end users. And then finally on top are the frameworks. And the frameworks are critically important because they bring in the high-level programming and scripting languages, Python and Java and so on that the data scientists and the end users expect to see. So with a platform like this from the top down, we're able to scale our solutions out into the market and allow the masses to access the high performance and efficient power utilization that you get with our underlying hardware technology. Down means forward. All right. So that's what a platform is to us. And platforms enable that broad set of application solutions. Here we have an example of our wheel, if you will, around compute acceleration. So we have a compute acceleration platform, and you look inside the inner circle on the left, there are subsegments. So video streaming, HPC, life sciences, machine learning, financials, and so on. So each of those subsegments is enabled by the essential platform that I was just describing on the previous slide. And then around the outside, you see a select few of our application ISV, software vendor partners that have used the platform to develop really high performance and compelling solutions in those verticals. Our application ecosystem then is our way to bring joint solutions to the end users and the data scientists that I was talking about before, and there are different ways of deploying that. We have cloud, so there are multiple cloud-based cloud vendors, cloud service providers that offer what's called FaaS, FPGA as a service. Those are up and running today, Amazon AWS, Nimbix, we have Huawei, we have Alibaba, and so on. So brand names in the space that offer cloud deployment options, not only deployment, but development options. And then now with the Alveo cards, we have on-prem. So users can buy off-the-shelf standard cards to plug into their servers and rack them up, and then all of a sudden you have an on-prem solution for your hybrid cloud into your private cloud. On the bottom right, you see a set of select application benchmarks, and we have some that have triple digits. I mean, we have some that are showing over 100x improvement running on a Xilinx acceleration platform as opposed to pure CPU. And we have some that are in the 10x, and they all demonstrate very compelling TCO advantages to end users. A little bit more detail. So each of these select partners that we have here line up with application subverticals, be it database acceleration, machine learning, video, financial, high-performance computing, and life sciences. And you can kind of, I'm not going to read through all of it, but you can see that it's a fairly varied set of applications that run on our platform. And our platform's adaptable, and it's essentially adaptable, programmable hardware. So with the platform now, we can move at the speed of software and allow application developers to work with us to develop complete solutions for the end user and the data scientists. And that application ecosystem is growing rapidly. Today, we actually have 65 complete applications in our ecosystem, and that is growing every day. We have trained, in the past year, over 3,000 developers on our platforms. So let's double click into compute, storage, and networking. So on the compute side, here's a photo of the Alveo U280 card, which is available today. And this is being shown in our booth. The U280 actually uses an underlying FPGA that has HBM, high bandwidth memory, 8 gigabytes of it. So a partner, good partner of ours, Adaptable, has running on a Dell EMC server, standard server, with an AMD EPYC CPU in it. They're running RocksDB, and they're accelerating that workload using Adaptable's no-load software. So what no-load does is allow you to talk to the acceleration card, which is a PCIe card, using the NVMe protocol. So you're talking to it like it's a storage device, but there's no storage I mean, there's DRAM, but there's no non-volatile storage on it, okay? It's an accelerator. So you get it to accelerate the workload underneath the RocksDB by talking to it over NVMe. Really, really convenient and software friendly and transparent. So that's showing 6x the transactions per second with RocksDB and 2.5x the processor efficiency. So your CPU utilization goes down by 2.5x, and yet your application performance goes up by 6x. Easy to deploy with no load. That API, it's integrated into the RocksDB software stack. So really good example of something that's ready for deployment now. Anyone can use it, evaluate it, buy it, deploy it. So let's switch from compute to storage. So with storage, we very aggressively partner with a number of third parties on the hardware side to enable the applications and use cases that you see on the left column there. So very typical ones in storage: compression, encryption, erasure codes, dedupe. These are quite useful and common. Key value store, and so on. Even video acceleration and telemetry directly in the path of storage. So for storage, we see two different use cases. One is storage aggregation, the aggregation of all the storage endpoints, and the other is the storage endpoint itself. So interestingly, and maybe counterintuitively for some of you, FPGAs can live in both places, even in highly constrained environments like you see on storage endpoints. I'll draw your attention to the right with Samsung. So in our booth, you'll see running a 1X and a 4X Samsung Smart SSD. So that's an SSD, PCIe SSD card with a Xilinx FPGA on it, and the flash. So this is called near storage compute. And I'll talk about that a little bit more in a minute. ScaleFlux was one of the earliest companies, if not the first company, to develop this use case, and they call it computational storage subsystem, CSS. They have a PCIe and a U.2 form factor with Xilinx FPGA on it. So they can show, so there's also smart IOPS, and by the way, Micron has an NVDIMM with a Xilinx FPGA controller there doing value-added software as well. So highly constrained environment, but really big benefits at the system level. On the storage aggregation side, we have partners like Molex that acquired Nalitech. They have a device that can talk NVMe over fabric to the network, and then on the back side, it connects to all the drives. So this could be a front end for a JBOF. So you don't need a more expensive or power-hungry CPU. You put in one of these things, and now you get the adaptability of the FPGA, and you get the performance of adaptable programmable hardware. Really powerful solution. Fidus has a similar one, and then I was talking about the Idetacom a little while ago. So in our booth, you will see our partner's BigStream, our partner BigStream, running on Samsung Smart SSD that I was just talking about. The application is Spark. So they're doing big data filtering and searching on a large database, and they're seeing on 1X, they're seeing one card. The application runs 4x faster than the CPU. Actually, I think it's 6x. And then when you scale that out to 4 cards, they're seeing about 24x the speed up to do the query. So really powerful acceleration. All I did was take a standard server and put in the Samsung Smart SSDs with the Xilinx FPGA on a storage platform connected to what I was talking about in the beginning. And Spark. Most of you probably understand Spark and Tableau. These are standard applications. So come see that in our booth. Now, the next challenge is network acceleration. As Nick Tizanovic was saying when he did his talk on the expo floor, I'm not sure if any of you were there, but the phenomenon of Moore's law trailing off, you see that here as the compute cycles per server is not growing as fast as it is. Still growing. It's not growing as fast as it used to. But port speeds are now growing very fast. So it's outstripping the CPU's ability to handle the network processing, which arguably they're not, I mean, hardly arguably, they're not very good at. CPUs are not built for networking type of workloads. So this is a problem. This is a problem, and it's getting worse over time. No, we have a solution. You may be wondering, why am I pushing the button when all I have to do is hit the space bar? Okay, so we see a solution to this problem for networking types of workloads. If you look at traditional NICs decades ago, the NIC was ASIC-based and simple. Its job was to translate packets to PCIe buffers, frames, whatever you would call it. So that's all it was asked to do, and the CPU would do the rest of the work. Now, when smart NICs in around the 2010 timeframe started to become a thing that people talked about, they were built using what was available, which were SoCs, comms processors typically. And running networking workloads on an SoC is basically shifting the problem from, let's just say, an Intel-based CPU and the host to the NIC running on an embedded ARM or MIPS or some processor like that. So you haven't really gained much by doing that. And so some of the leaders in the industry, such as Microsoft was very public with this in Azure, they came up with an architecture similar to what you see in the 2014 timeframe, which was the NIC plus the FPGA on the same device, on the same NIC card. This had an advantage of giving you the performance of the FPGA, but also the I/O and all of the protocol richness that you would get from the ASIC. But that's not the end game. The end game, we feel, is enabled by the thing on the right. It's an all FPGA smart NIC, and I'll show you what you can do with it on the next slide. But this is something that we're showing in our booth today running. So this is the future of smart NICs. Why is that? So with a basic NIC, you can do basic NIC functions. And as NICs become smarter and they need to do more, and you progress from the left to the right, you see that the first types of offloads that were enabled on these NICs, these smart NICs, were network offloads, network virtualization, classification, VLAN, VXLAN, these types of things. Then it moved more towards storage offloads. And finally, on the rightmost, the ability to integrate network storage and compute, everything in that triad that I was showing in the very beginning, having all of those workloads run on one device, on one piece of hardware and one piece of silicon is very, very powerful. So today, we are unveiling and demoing with our partner SolarFlare a 100 gig NIC, high performance and low latency running in our booth. So come see us at A15 on that. So we're moving as rapidly as we can towards the vision on the right. This is what that demo looks like. It's a card that was built by SolarFlare for the purpose of this demo. And it's a full height, half-length card. It's a little bit more than half-length when you add the fan on the end of it, but it's a 100 gig NIC. It's integrated all on a single Xilinx FPGA. It's adaptable and it's extensible, so you can change its functionality and you don't have to wait the ASIC cycle for the next new feature to come. And it's extensible, so our partners and our end customers can use the platform tools that I was talking about to extend the functionality. Again, moving at the speed of software with the benefits of a hardware-based solution. So we are showing 100 million packets per second running in each direction, so a total of 200 million packets per second running through this NIC up into a DPDK driver. So that should show the promise of what we can bring together, Xilinx with our ecosystem partners, to the end users for this vision of the smart NIC. All right. So finally, we have very flexible deployment options. We're a semiconductor company. We're transitioning into more of a platform company for the reasons I was just talking about. We still sell silicon, and we have hardware partners that take advantage of that. We have our own hardware with our Alveo production boards, and more coming. And we have our FAS partners in the cloud that offer FPGA as a service as a way to deploy for developers, and for end users both. You can actually go on our website and see our application partners and get a lot more information about what they do, what they accelerate. And so there's the link. You can choose a category, multiple applications per category. And some of the apps have a video demo, so you can watch that and actually see the proof points. And they have a link for more information, so you can read about that and also tells you what boards are supported and what the speed up is versus CPU. So this is our way of scaling out to as many eyes as possible what solutions we have available. So finally, Xilinx FPGAs is the underlying technology that enables compute, storage, and network acceleration for data center workloads. We have hardware performance, high performance, high throughput, low latency solutions, very compelling TCO advantages across many applications. So hardware performance at the speed of software. We offer platforms, a rich set of IP, tools, silicon and board level solutions to enable users, from the ones that want to touch the hardware and optimize everything, going up the stack all the way through the frameworks for the data scientists to use the programming frameworks and portals that they're used to, languages that they're used to, and get the benefit of the acceleration in the data center. So please, I invite you to come see our new networking demo in our booth number A15, and not only networking, but we also have the Idetacom demo and the Big Stream demo running on the Samsung Smart SSD. So Xilinx, we're on a journey. We're enabling data center acceleration as a platform company to build the adaptable, intelligent world. Thank you all for coming.